All right, so this is a problem from the chapter, or from the very end of the chapter 3.3.2, yeah, notes. This one here, they want us to find the zeros. Okay, and so we're going to factor this down, and we found that one of the ways we're going to have to go about this, finding the zeros, is to list all the possible rational zeros. And we found that the way we do that, zeros, is to list, okay, the factors of the constant, okay, where 14 is the constant here, or positive 14, all over the factors, okay, of the lead coefficient. I can't spell coefficient. Anyway, that's probably wrong. And the lead coefficient here we can see is 1. So if we list all the factors of that, the factors of 14 are plus or minus 1, plus or minus 2, plus or minus 7, and plus or minus 14, all over plus or minus 1. So, listing these, it gives us a good idea of what we should be looking for when we go ahead and graph our function. So I already plugged that into mine here, and I'm going to cover up part of the problem so you can see my graphing calculator a little better. So we hit graph, and we can see here that we have this graph. Now, one of the things I like to do, even before I look at my table or I try to calculate the zeros, is to go ahead and eliminate any that don't make sense. So I know that this is a third degree polynomial, so I'm looking for 3 zeros, okay? And I see here that I have 1, 2, and 3. Now this third one's only up at about 7 or 8, somewhere in that neighborhood. It's nowhere near 14, so I know I can immediately eliminate 14. This one looks like it's right around -2, that one's about 2, and this one might be about 7. So I'm going to want to hold on to the rest of those, but I want to get any factors or possible rational zeros or impossible rational zeros out of the way right off the bat. So now I'm going to go ahead and take a look at the table, and what I'm looking for is I'm looking for anywhere where y is equal to 0. Okay? And you can adjust the values of the table if you play around with your calculator, but we can look and we see here that, well, y is equal to 0 when x is -2. And so that meaning that x equals -2, which is one of our possibilities, okay, is a 0. Now, another way you can go about this is to go back to the graph. You can hit calculate the 0, and might take us a sec to get around there. Oop, I'm going the wrong way. Okay. So if we go back all the way over to our point over here, it's asking for the left bound, so we can hit the left bound, the right bound, okay, and to guess, and it would also get us this value. Again, that's second, calculate, and you hit 0, and then enter the left and right bounds. Now that we have one of our zeros, we can go ahead and attempt the problem. Now, I only looked for one because this is a third degree polynomial, so if I can find one of the zeros, that'll get me down to a quadratic, and I can factor or use the quadratic formula. So in this particular case, I'm going to use x equals -2 for my synthetic division, and my coefficients are 1, okay, and are 1, -7, and -11. So I drop that 1 down, okay, and I get -2 times 1 is -2, add -2 and -7, and I get -9. -2 times -9 is positive 18. Combine those two together and you get 7. So I already, oh, and we were supposed to have a 14 over here. I was wondering why I didn't have a remainder. -2 times 7 is -14, and we get a 0 right down here. All right, now I see that -2, in fact, does absolutely have to be a factor because I have a remainder of 0. And I can rewrite my equation. Now, I divided by x plus 2 in the end. That's our factor. And so I know that this is now going to be x squared minus 9x plus 7. And I, again, want to find when that is equal to 0. Now, in this case, you can go ahead and do your x, but I notice that there's no way I'm going to be able to find a number that multiply, or two numbers that multiply to equal 7 and sum to equal -9. So I'm going to go ahead and use the quadratic formula. Okay, x is equal to negative b, so -9 plus or minus the square root of b squared, -9 squared. Okay. Minus 4a is 1, c is 7, all over 2 times 1. Now, moving on from there, we do some math to simplify. We get a positive 9 out here, plus or minus. Well, this is going to be 81 minus 28. I can't do that in my head. 7, which is we're going to get square root of 53 here, all over 2. Okay. All right, and someone can correct me if I'm wrong, but I believe 53 is a prime number, so there's no way we can simplify further. So our roots, or our zeros, are going to be x equals -2, or the set of -2, and then we're going to have 9 plus the square root of 53 over 2, and 9 minus the square root of 53 over 2. All right. Now, one thing that they asked, or we want to double check, is they did say to find the zeros. These are in fact the zeros, but if they wanted us to go ahead and find the factors, or write it as a product of factors, we could do that as well. Okay, so this is saying that x is equal to -2, x is equal to 9 plus the square root of 53 over 2, and x is equal to 9 minus the square root of 53 all over 2. Okay? If we go ahead and we subtract all of these from one side, we're going to get x plus 2, or in this case add, is equal to 0. X minus, and I'm going to put this in parentheses, 9 plus the square root of 53 all over 2 is equal to 0. Okay. And lastly, we get that x is equal, or x minus 9 minus the square root of 53 over 2 is equal to 0. So we can end up writing that f of x is in fact a product of all of its factors. So I can write x minus, or plus 2 times x minus 9 plus the square root of 53 all over 2 times x minus 9 minus the square root of 53 all over 2. Okay, and if you multiplied all these back out, unless I made some sort of arithmetic error, which feel free to call me out on it in class, you should get right back to our original function right up here.